Welcome, I'm Isaac, and today we'll be going over the process I used to build wheels here at Olympia. Wheels are a mystery to most, so I just wanted to share my way of building them. I won't necessarily be going over all the steps in theory to properly build a bicycle wheel, since I'd like to keep this as straight to the point as possible. With a quick sip of coffee, let's take a look at the parts our customer brought to us. The rims are a pair of DT Swiss R500 DB, and will be laced to a good-looking pair of green anodized Milwaukee single-speed hubs. Measuring spoke length. The first step to building any wheel is calculating correct spoke length. The process involves some math and some measuring. I use a pen and a paper, a vernier caliper, an eye gauging hub measuring tool with a hub stand, and a calculator. I also use a pair of dedicated identical measuring spokes. I always start by doing a quality check on the parts to make sure they're not incompatible or damaged. I start off by locating a spoke drilling on either side of the valve hole, and then passing a spoke and nipple through it. I then look for the opposing spoke drilling, where I do the same thing. If I have a hard time finding it, using the rim seam as a reference point speeds things up for me. Using my vernier caliper, I measure the distance between both spokes and add it to their total length. This gives me the effective rim diameter, which I note down. Next, I'll use the digital height gauge to take all necessary hub measurements. Although this can be done using a caliper, the digital height gauge is much more precise since it sits on a flat surface and can be operated without touching the hub and impacting results. The process is identical for both hubs. Using a vernier caliper, I'll measure the flange diameter from the center of opposing spoke holes. All measurements are noted down. On my laptop, I open my favorite spoke length calculator and enter my measurements accordingly. There are tons of spoke length calculators out there, but since this was a straightforward build, I used Pro Wheel Builder, as it keeps things quick and easy. When all our data is entered, the spoke length calculator will output the correct length for this build. Once I have my spoke lengths, I lower my table and get ready for lacing. Since wheel building involves meticulous handwork and repetitive movements, it's very important to have a workspace that allows for comfort and speed. I use a spoke cup which cannot be tipped over. The spokes will fan out, making them easy to grab and improving my speed when lacing. I also use a Wheel Fanatic pin vise and a nipple shaker to speed up the lacing process and avoid dropping nipples into the rims section. When lacing, I start off by predicting what spoke hole must be used first in order to align the logo of the hub with the valve hole. This step isn't necessary, but it's a detail that separates the home builder from the professional. I proceed by placing my lead spokes, and then preloading my hub by rotating it away from the valve. I laced this particular set as a 3-cross. I usually have the spokes in the cup sit in linseed oil when lacing, but since this build was most likely going to be beat up a bit, I decided to add thread locker as spoke prep. The thread locker I use settles in when everything is threaded together. I apply it before truing the wheel, as it helps lubricate the threads during the process. At this point, we have a fully laced wheel. The final step is wheel truing. Truing a wheel means increasing the tension in the spokes until the wheel is a strong and stabilized system. A wheel that is true is straight and has equal tension all over. This stage of the wheel building process is one of the most overlooked and misunderstood concepts in bicycle mechanics. A properly tensioned and true wheel can last for years on end. Today, most wheels are machine built and will never match the quality of a set built by hand. What seems like simple tightening and loosening of the spokes is actually an immensely precise and scientific process, which also makes it the longest and most poetic part of wheel building. This is where science, concentration, and experience come together to create one of mankind's greatest inventions. Wheel truing is where masters are made. In silence, the wheel's tension is gradually increased until it reaches the desired value. The wheel's spokes are stress relieved to remove any spoke windup or structural inconsistencies, which are afterwards corrected. And that is my main wheel building procedure.